If everything you've seen from the James Webb Space Telescope has already convinced you that we're entering a new era of astronomy, this discovery pushes that idea even further. Hidden within a stream of infrared observations from a distant star, astronomers uncovered evidence that may represent one of the strongest signs yet of a potentially life-supporting world beyond our solar system. At first, the data looked routine. As a distant planet crossed in front of its star, a tiny fraction of the starlight filtered through its atmosphere before reaching Webb's instruments. That faint light carried a chemical fingerprint, allowing scientists to identify the gases surrounding the planet. Discoveries like this have become increasingly common, but this time the results stood out immediately. The atmosphere contained water vapor, methane, and carbon dioxide, molecules that already make a planet especially interesting. Then researchers identified another compound that drew worldwide attention, dimethyl sulfide, or DMS. On Earth, this molecule is primarily associated with biological activity in marine environments. While scientists remain cautious and emphasize that additional observations are needed before any extraordinary conclusions can be made, its possible presence has made this planet one of the most exciting targets ever examined. The statistical confidence of the detection is far stronger than what astronomers normally encounter during early observations. Although no responsible scientist claims that extraterrestrial life has been confirmed, the findings suggest that this world deserves far more attention than anyone expected only a few years ago. The planet, known as K218b, lies about 120 light-years from Earth and orbits a small red dwarf star within its habitable zone, where temperatures may allow liquid water to exist. Unlike Earth, however, this is not a rocky twin. It belongs to a category known as super-Earths, planets larger and more massive than our own, often surrounded by thick atmospheres rich in hydrogen. For years, scientists believed these hydrogen-dominated worlds were unlikely places to search for life. New observations are beginning to challenge that assumption. Instead of appearing hostile, K218b seems remarkably stable. Current models suggest temperatures that could allow liquid water to remain present beneath its dense atmosphere. That thick blanket of hydrogen may help trap heat efficiently, reducing dramatic temperature differences across the planet and creating a more consistent global climate than many worlds experience. Because the planet's gravity is much stronger than Earth's, it is also far better at holding onto its atmosphere over enormous spans of time. Rather than slowly losing gases to space, as happened on Mars, K218b may have preserved a stable environment for billions of years. Its parent star also plays an important role. Red dwarfs burn much more slowly than stars like our Sun, remaining active for trillions of years. If conditions suitable for life developed early on K218b, they may have persisted for extraordinary lengths of time, giving any potential biology far longer to evolve than life has had on Earth. This possibility is changing how astronomers think about habitable worlds. Instead of searching only for planets that closely resemble Earth, researchers are now expanding their search to include larger, hydrogen-rich planets that were once considered poor candidates for life. Another intriguing clue comes from the planet's atmospheric chemistry itself. Certain gases detected by Webb appear to coexist in combinations that are difficult to explain through simple geological processes alone. On Earth, similar chemical imbalances are maintained because living organisms constantly replenish specific gases that would otherwise disappear through natural reactions. Researchers are carefully investigating whether a similar process could be occurring on K218b. While non-biological explanations remain possible and further observations are essential, the unusual atmospheric composition has elevated the planet to the top of the list of worlds deserving continued study. If these findings continue to withstand future analysis, K218b could become one of the most significant discoveries in modern astronomy. It reminds us that life, if it exists elsewhere, may not require a planet that looks exactly like our own. The universe may support living environments in forms far different from anything humanity originally imagined. And this may only be the beginning. Every new observation made by the James Webb Space Telescope adds another piece to a puzzle that is steadily transforming our understanding of where life might exist among the stars.